So this video is going to be on the group 7 halogens, and we're going to start with the properties. So first we need to know the type of halogen, the formula for that halogen, the standard physical state of the halogen, the colour at this state, and any further information. So fluorine has the formula F2, and what you're going to notice is all the halogens are diatomic, which means they go around in twos. So for fluorine, its physical state under standard conditions is gaseous. It's a pale yellow colour, and something that's worth knowing is it's a highly reactive gas. Next we have chlorine. Chlorine goes around then Cl2. It's also gaseous under standard conditions, and it's a green colour. And the further information for this is it's poisonous in high concentrations. Thirdly, we have bromine. This goes round as Br2, and its standard physical state is liquid. The colour of it is a red liquid, however this one gives off dense brown fumes, and these are poisonous. Finally, we have iodine, and this goes round as I2. This is both a solid and a gas under standard conditions, and that's because iodine will sublime from a solid to a gas, and what sublime means is basically it will change without going through a liquid process between the two. And the colours, well, the solid is a shiny grey colour and the gas is a purple gas. So we need to know the melting points. So the melting points of the group 7 halides increases as you go down the group. The reason for this is because there are more electron shells, which will cause there to be greater van der Waals forces between the molecules, and that's the key phrase, shall I say. And these then require more energy to be broken. We also need to know the atomic radius. Well, this kind of ties in with the last point. This will increase down the group, and this is because there are more electron shells which will repulse from one another, therefore increasing the size. Also there's more electrons, but the main point is more shells, more repulsion. Now we have electronegativity, and this decreases down the group. Yet again, it's because of the electrons, and it's because these become further away from the positive nucleus, the protons, and due to the increased shielding and repulsion, this weakens the electrostatic forces of attraction. So what we also need to know, and this will come into use for the next video, is the halogens, the halides they form, and the colours of the halides in solution. So for chlorine, the halide of chlorine is chloride, and chloride in solution is colourless. Bromine produces bromide, and the colour of this halide is orange. Finally we've got iodine, and this produces iodide, and this is brown in solution. We don't need to know about fluoride, but fluorine is the halogen and fluoride is the halide. Okay, so that's it for this video. The next one will be about the displacement reactions.